For the first experiment here on our friction lab, we're going to look at the difference between static friction and kinetic friction. I currently have a block with two 250 gram masses on it. I have a force sensor that I've connected to my LabQuest. I've set up the LabQuest. What I'm going to do is I'm going to pull it just before it starts to move. That will be the force of static friction, so the force that is resisting the start of motion. I'm going to go ahead and zero my LabQuest out to start off with a zero force. And then I'm going to pull it super slowly just until it's right about to move. And that will be my static friction value. I'm going to do that 3 times. All right, here's my first one. So I got a max reading there of 3.7 newtons. So I'm going to write that down. I'm going to do it 2 more times. I got a 2.7 value there. I'm going to zero it 1 more time. I got a 2.8 value there. To use your average is probably around 3, which makes sense. Now I want to pull it at a constant velocity and see what that force is going to be. So once I got it moving at constant velocity, I got around 2.2. I'll start again. I got 2.9. I got 2.6. So we can see that the kinetic friction values are lower than the static friction values. For this next one, I'm going to be changing the mass of the block. So real quick, I have to go get the mass of the actual block itself. So the mass of the block is 149 grams. And what I'm going to do is I'm going to add, first of all, I'm going to do it with no masses on top, so just straight 149 grams, which we'll have to convert to kilograms. And then I'm going to add these 2 bar masses on top, which are each 250 grams each. The first one will be a total of 149. The next one will be a total of 149 plus 500. I'm going to record the kinetic friction value for each one. Okay, so around 0.47 for the first trial. This is going to be the small mass, so I'll put it right here. Here's my next one. I'm going to zero out again. I got 0.3. My last one, I got 0.5. On the left-hand side here, I'm going to do it for a larger mass. So I'm going to put my bar masses on top now. I'm going to go ahead and zero it out. One was 2.3. Do it 2 more times. I got 2.3 again. That one was 2.1. So we can clearly see for the larger mass, it requires a larger force to keep it at a constant velocity. So on the left here are my different combinations, what I'm going to do. So I'm going to be pulling each one at a constant velocity. I'm going to have 2 bar masses on top for every trial. I just want to maximize that friction just so I can get a little more of an accurate reading. So for the first one, I have the felt side down on the block, and I'm going to pull it across sandpaper 3 times and get an average kinetic friction. So for the first one there, I got 2.8 for trial 1. I'm going to go ahead and do the second one. I got 3.5. Last trial. I got 3.2. So obviously a lot of friction there. For my next run here, I'm going to have the wood side down. So I'm going to flip this over. I'm going to have the wood on the table, and then I am going to be pulling it on the table itself. So this is made of epoxy resin. So I'm going to pull that 3 times. So I got 2.1 for that first trial. $2.0 for the second trial. And 2.1 for the third trial. For the last one here, I have the felt side down, and I'm pulling it on an aluminum track. Let me go ahead and zero this out. This one I got 1.8. Second one here, 1.7. $1.7. And that's all the data that you need.